So welcome everybody to ZEDEDA Transform. This is the remote monitoring for industrial operations session. And thank you all for joining in this session. So today we have the honor of three great speakers joining us from Advantech, Aero, and Dianomic. Myself, I'm John Auld. I'm a sales director at ZEDEDA here. But I'm going to take a quick moment and have our speakers do an intro, and then we'll just dive into the session if that works. And we'll start with David.
Yeah, I'm David Liu. I'm the Director of IoT Solutions and Strategic Alliance. I've been working with Advantech for 25 years and in charge of strategy and alliance in Advantech North America. Thank you, John.
Thanks, David. Roland?
Yeah, thanks, John. My name is Roland Ducote. I'm also a director focused on IoT solutions with Aero Electronics, specifically the Aero Services Division. And I spend most of my time putting together those solutions for our partners. Thanks, John.
Thanks, Roland. Tom?
Yeah, thank you, John. I'd like to also thank ZEDEDA for including us. My name's Tom Arthur. I'm CEO of Dianomic, and we're building and contributing Fledge to the Linux Foundation Edge, and I'll be talking about that shortly.
Great, thank you guys all for joining. So today I'll just do a quick intro of the session itself. So when we talk about remote monitoring for industrial operations, just to kind of frame up what we're going to talk about today is companies go through digital transformation. They ultimately get to this tricky divide that bridges the IT and the OT network, and that's what we call the IoT edge. The question becomes, what's the best to deploy a flexible architecture that allows me to get the data out of my operations and support the various business side use cases, which may be dealing with AI or ML at the edge, maybe running an OEE application. There's a lot of security concerns. So today's session, we're going to address this question and show you how this stack is built from the hardware to the applications and finally the services and the support. So we're going to kick the session off with David Liu from Advantech. And David, well, and the graph we built up here, this is kind of how everything fits together. We have the hardware pieces of it from Advantech coming in. Fog lamp will be introduced from Dianomic on the application side, and then Aero kind of brings the whole thing together from a deployment support services. And that's the kind of flow we'll go through today. So at this point, I'll hand it off today.
Thank you. Thank you, John. It's great to be here and share Advantech technology and strategy to be your trust partner for edge intelligence in many industrial IoT applications. Of course, including the remote monitoring, which has been very critical and always on the front line to determine the success of any IoT project. Next slide, please. John is, yeah. So, I'm in charge of strategy and alliance in Advantech Industrial IoT Group in North America. I've been with Advantech for over 25 years and witnessing the success of this great company. Advantech was founded in 1983. In the past over 35 years, Advantech built up the global presence in 16 countries and over 92 cities to provide technology, product solutions, logistics, and support in industrial IoT edge intelligence to ensure the success of our valuable partners and customers. Next slide, please. To support valuable partners and customers, Advantech is devoted to focusing on 4 go-to-market sectors: general automations, app factory, industrial equipment manufacturing, and industrial infrastructure, including oil and gas, new energy, environmental monitoring, transportation, and so forth. Remote monitoring has been one of the most important applications from our customers and partners to demand the product and technology. Next slide, please. To structure the reliable, repeatable, and intelligent edge solution, especially from remote monitoring project perspectives, we cannot miss any of the key layers, including edge sensing, industrial communications, and edge computing. Can you go back to the previous slide, please? Thank you. So edge sensing devices take care of the both green and brown fields, various edge device protocol to connect the unconnected. Both wire and wireless solutions here facilitate decentralized remote and outdoor IT applications through LoRaWAN, low-power WAN, NB-IoT, LTE-M, Wi-Fi 4G, even 5G going forward with IoT protocols such as MQTT, constrained application protocol, live end-to-end, and so forth. Industrial communication layers is to structure the reliable and secure machine-to-machine network through industrial internet switches, protocol gateways, data gateways, devices, servers, routers, and so forth. They are capable of transmitting critical and sensitive information. There are also purpose-built edge computing for various industries, such as compute for oil and gas, come with C1D2 and ATEX anti-sprucing feature, compute for electric energy designed for IEC 61850 standard, compute for railway, vehicle, and other mission-critical applications must be designed to meet their specific standard industrial regulations in terms of electrical and environmental requirements. These capabilities make Advantech stand out, become the #1 industrial computer manufacturer for many years, and made a huge differentiation from others. Next slide, please. Yeah. To complete the successful remote monitoring projects with edge intelligence, I have to talk about the strategy with Advantech valuable alliance partners. By providing the reliable end-to-end network in terms of edge sensing, communications, and computing, as the pillars and foundation to work with all alliance partners to build up the IoT highway as a carrier to accelerate customers' technology, solution, and services to fulfill the demands. The open ecosystems can certainly be the efficient and effective framework to make all this to happen. And Advantech is pleased to work with ZEDEDA, Dianomic, and Arrow, and many other alliance partners to drive the business together. Next slide, please. The strategy of Advantech to work with partners is focused on edge intelligence. Advantech has many edge software solutions work across multiple industries to connect edge to cloud, as well as facilitate various industrial protocol. On the other hand, Advantech is also actively working with partners to provide edge bundle solutions. For example, ZEDEDA's Eve and Dianomic VLAN solutions for the dynamic requirements from the multiple industries. Therefore, our valuable partners and customers can receive the reliable, repeatable, and intelligent edge solution to accelerate their business and services. Advantech is also looking forward to work with a partner to co-create the end-to-end services which will drive innovations and new growth engine furthermore. Next slide, please. Many IoT projects and collaboration eventually go to the dead end because of lacking a path to effectively evaluate and quick respond the result. Sometimes people is too aggressive and too early to jump to the end-to-end solutions without systematically aggregating and orchestrating building blocks in each critical layers. Sometimes people are too conservative to move out the first step. By providing these 3 simple steps through edge solutions, Advantech and alliance partner can always work hand in hand to enjoy the success of business. In the next, Tom Arthur, CEO in Dianomic, will share the example how Dianomic work with Advantech and other alliance partner to pave the path to success. Thank you, and let's welcome Tom.
Thank you, David. We could go to the next slide. Thank you, everybody. Dianomic, we're a startup company starting about 3 years ago as the brainchild of Pat Kennedy, who is actually the CEO and founder of OSIsoft. And for those familiar with OSIsoft, they build a historian that's deployed in about 22,000 in process manufacturers today. So across energy, oil and gas, pharma, pretty much food and food processing. So any process manufacturing. And what's happening to them is exactly what Saeed and Jason talked about. And that is there's all kinds of new workloads and new opportunities in manufacturing to automate machines. And while doing that, though, there's a brown field that already exists. There's already a SCADA system. There's already a DCS system. There's already a historian. There's an MES or an OE in place. And those systems are not going away. So how could we possibly help bring in IIoT and integrate it with the current manufacturing processes? And that's what started the company Dianomic. So today we supply 3 products. FogLamp, it's an open source framework for the edge, for the industrial IoT edge, to build applications and connect data. FogMan, which is an enterprise system management to manage IoT applications, working in conjunction with Eve. And Fog AI, an effort we're doing with Google to bring advanced machine learning to industrial processes, improving OEE. Next slide, please. So let me start with FogLamp. FogLamp is a set of microservices designed to integrate and connect industrial data and processes. And what's unique about industrial over, I would say, retail or you find in smart cities is there's an infrastructure there that's existed for the last 20, 30 years, and it's an expensive infrastructure. So if you look at the ZEDEDA slide that talks about an open API connecting to any on-prem system, what is the on-prem system for manufacturers? So it's the SCADA system from ABB or Emerson or Rockwell. It's the OEE systems for making sure your optimizations are there for all your quality. It's your MES systems that are instructing your PLCs that I'm doing cookies today instead of some other across my manufacturing line. And it's your historians that are keeping track of your factory going together. So industrial IoT has to connect all of these existing systems that are currently on-prem in these manufacturing environments. But what's happening in manufacturing, and we're trying to capture this idea on the bottom of the FogLamp slide here, is there are brownfield systems and there are new greenfield systems that aren't connected to SCADA or the DCS. So these new industrial IoT frameworks, they need to connect all the assets that are not connected to SCADA. But not only that, they also need to connect to SCADA assets. Let's say I'm a food processing company and it's a centrifuge that's purifying my oil. And I want to bring machine learning to my purification process. Well, that would be an action of machine learning. So your industrial IoT needs to capture all of these capabilities, connect all of these data, and manage these new workloads. But not only that, it also needs to connect to the cloud, as many of the industrial manufacturing systems are starting their migration to the cloud. So when we started Dianomic, we coined the term FogLamp, which almost tells you exactly what it is. The idea of fog computing that Cisco coined several years back, but also LAMP is being cute in that, of course, FogLamp's on a car, but it's more about the LAMP stack. So for those that are familiar with web application development, LAMP, Linux, Apache, MySQL, and PHP, drove web application development and really created the fuel that helped web applications from a Facebook to an e-commerce site all work. So with that in mind, FogLamp, an open source stack we created with several partners that I'll talk about on my next slide, and began working with many third parties in helping them build out applications for condition monitoring, predictive maintenance, greater efficiency, higher quality, situation awareness, and safety, common applications you find in industrials. Next slide, please. So with that in mind, FogLamp was created and has been deployed now in about a dozen different manufacturing environments. Working with Google and OSIsoft, Nokia, FLIR, and several others, we made the strategic decision and joined the Linux Foundation Edge along with ZEDEDA and about 66 other companies as a founding member. And we contributed the FogLamp stack to the Linux Foundation Edge to help drive IoT and its future. When you contribute a code stack to the Linux Foundation, they own the brand. And the brand that you'll find in a GitHub repository today is called Fledge, Fog Lamp Edge. And we created the little icon there of a peregrine falcon wearing a hard hat and marrying it up, of course, with Tux, the Linux Foundation. So Fledge is to Fog Lamp, for those that understand Linux, as Fedora is to a binary from, let's say, Red Hat Enterprise Linux 8. So you can get full supported Fledge binaries from Dianomic today from this contribution that we, Google, and OSIsoft gave to the Linux Foundation. Next slide. So I'd rarely ask one to read a slide, but this is the Linux LF Edges slide on why Fledge and what we're trying to do. So I'm going to give you just a minute to read the slide, and then I want to talk about the last bullet. Really, this last bullet is really critical, I believe, in an open source strategy. So industrials are new to open source, and open source is actually new to industrials. When you go into industrial environments, there are hundreds of proprietary protocols and thousands of different data mappings that haven't been standardized. So there's a true opportunity to really address the diversity and complexity of industrial systems with an open source strategy. So it's not just about the technology. Like the LAMP stack, it's about driving a community with the Linux Foundation Edge as we all make Fledge enabled to help these new kinds of workloads occur in industrial applications. Next slide, please. So what exactly is Fog Lamp? And John, you can just advance through this. So what are this? So Fog Lamp Fledge is a set of microservices that sit in an edge computing device and do the following functions. Quite literally, they can collect data, or Fledge can collect data from any and all sensors, and we mean any. It can transform and filter that data in flight. So from the sensor all the way up to the cloud, you may need to do transformations. It could be something as simple as converting Celsius to Fahrenheit, or something very complex through a Linux pipe. Often these deployments are in areas where networking may not be very reliable. So it includes buffering. So you don't want to lose any of that data. And once the network restores itself, it will forward the data. It can act on that data. So there's an event engine where you can analyze all this data on the edge and actually send alerts and do actions based on some conditions that your application has defined. And it can also do edge analytics on the edge. So these can be as simple as some Boolean logic, less than, greater than some value alert, or something as complex as running TensorFlow Lite on the edge with a complex machine learning model that is helping you optimize a machine or predict its maintenance. And then last, Fledge Fog Lamp can send and deliver that data to any industrial system or the cloud. And that's critical in industrial places. So you might need to integrate with an OE system, an MES system, a historian, and the cloud. This data might go to that data might go here, and Fledge can support those complex routing equations across your data streams. Next slide. So I'd rarely read a slide, but when we created Fledge, these were the requirements that we think were important for an open source system for the industrial edge. So first and foremost, we believe that the users themselves should be able to control their data. Open source, in this case, really is about defeating the complexity and diversity you find in industrial applications. Another critical feature, of course, is it needs to be cloud agnostic, whether you're choosing AWS, Microsoft, Google, or whomever. It needs to be able to support those different cloud systems. And then it must be able to run machine learning on the edge. There are many, and I'll have an example of what we're doing with Google and what I mean exactly about running models and labeling data and doing the entire life cycle of models on the edge. It needs to collect data from any and all sensors, and it must be able to do that very easily with a mid-level engineer to write the code. It needs to support different kinds of telemetry. You'll find in industrials, for instance, let's just pick on vibration. You know, temperature is a rather simple data type, but vibration, if you're running a vibration sensor, let's say at 8 kilohertz, that's about 2 gigs of data an hour. And if I put 3 vibration sensors on a single pump on the XYZ coordinates, That's 6 gigs of data per hour, just monitoring vibration data from a single pump. How do you manage that on the edge? How do you support those workloads as part of the requirement of what we believe is a good IoT framework? Obviously, I've already spoke about it. It needs to integrate with your current systems. It needs to support the ability to be powered by batteries for remote locations or be powered up. It needs to work in low bandwidth environments to high bandwidth environments to wireless environments. And of course, critical to what ZEDEDA was saying earlier, it has to be secure, it has to scale out, it has to be manageable. Next slide. And you can just advance through this. So in our work with Google, Google is a contributor to FogLamp. Their first contribution was a plugin which connects FogLamp transparently with Google Cloud and all the machine learning tools you get from Google. So when you look at a machine learning application on the edge, generally the first step is what they call labeling data. You need to see the different anomalies that you want to actually catch with your machine learning. So you need to experience them. So I need to say, all right, here's my machine running normally, and here's my machine running with error 1, error 2, and label that data. As you send that data into the cloud, there you build your models out. And then once you have a model that says, here's what a cavitation looks like, you send your cavitation model out to FogLamp, and you run those models. And you might be distributing mini models out to the edge. And now your edge device monitoring that machine needs to interact with the operations of the factory and do the anomaly detection and the alerting with the operational systems, whether they're historians, MES, OEE systems, or other, or an IT system, and also send the results of that data to the cloud. Next slide. And why machine learning in industrials? And there's many different types of use cases. A common one today is around quality. You know, looking especially with computer vision techniques, you can look at welds, you can look at packaging and food processing, and in real time you can identify if the quality is as required or not before you continue your manufacturing process and integrate something with poor quality before it's too late. Or you might be using machine learning for safety. Are people in an authorized or unauthorized area? Or you might be using machine learning for tools around vibration data to actually detect and predict maintenance on machines as they go forward. Next slide. So in industrials then, and we heard this in the keynote, if you start looking at all of these various types of applications and how they can augment the current systems in manufacturing around SCADA and DCS systems, you can only imagine hundreds or even thousands, or in some cases in utilities, millions of new devices deployed across the plant. And in that, you clearly have a need to integrate all those devices, manage all those devices, and secure all those devices. So FogLamp is designed to connect to itself and be deployed in hierarchies or meshes as they aggregate that data, process that data, analyze that data from the sensor to the cloud or to any on-prem system. And as you can see, you can define in Fledged FogLamp, you might be sending that data to multiple locations, maybe your on-prem historian, as well as your Google Cloud for your machine learning. Next slide. So with that in mind, we've developed a service called FogMan, which is our management system of multiple Fledges or fog lamps. So what FogMan does is it manages your configurations and your applications sitting on top of Eve. So you can now set up, let's say, a profile of a pump, and you can define that profile, define the configuration, what it connects to, and you can back it up, you can manage it, you can update and delete, you can do rollbacks, you can manage the security keys for all these connections, and have a system-wide management of your industrial IoT deployments. Next slide. And I'll end with an example. So this is a use case that's public, one of our first customers. This is Jacksonville Energy. So to give you an idea of how you might be connecting industrial equipment, their particular use case, their utility in Florida, and believe it or not, they had their $1 million transformers and substations not connected to their Emerson SCADA system yet. And so what drove this application was the maintenance team responsible for maintaining these transformers wanted to install this Modbus device, this device built by Dynamic Ratings, which actually measures the oil pumps, are they working, the oil temperature, are they working, the fans, and the ambient air temperature around these transformers. That then has a Modbus output where FogLamp then converts that to a common JSON. And in that, it's running in an Advantech gateway out at the substation. And then it's alerting based on different conditions that JEA wants to monitor and forwarding that data to the current ISA 95 system, in this case, an OSIsoft Pi server, which they already use for monitoring transmission and distribution at the utility. But they also wanted the data to go to the maintenance team, which in the IT infrastructure is using a trouble ticketing system on Oracle. So in this case, FogLamp is sending through a native protocol called OMF to the Pi server and sending through Kafka to Oracle to inform the maintenance team when there are conditions they need to be alerted on about their transformers. And with that, I'd like to pass the baton to Roland, and thank you for your time.
Thanks, Tom. Hello, everyone. Thank you to David and Tom for their overview, and the ZEDEDA team for having us and putting this event together. For those of you who don't know Arrow, I'll provide a quick overview, then speak to our activities in this space and where we fit in the model and the ecosystem. So as mentioned, my name is Roland Ducote, and I spent a lot of time working on our Alliance program, focused on bringing together solutions from multiple vertical markets and applications. For context, Arrow closed fiscal year, which is the same as calendar year 2019, at $28.7 billion, and we have about 175,000 customers. So we're founded in 1935, and we focus really on electronic components and computer products and related services. So I think why that's important is, as David and Tom reviewed, industrial IoT solutions are complex and really require a wide variety of skills to bring to market. Tom talked about security and the deployment of these and management of these devices as they get into the thousands or the millions. And so that's part of the situation that we're living in today in terms of IoT deployments. Additionally, we see technology increasing at an amazing pace for both products and related services from different technology providers. We think this brings a really unique set of challenges. The complexity of these solutions require an ecosystem to implement, in most cases during POC and certainly in production. The ability to scale edge computing technology across the enterprise brings a lot of the technology challenges that Tom talked about, but there are a lot of business challenges as well. So the ability to get these things deployed at scale, both in at certain time horizon and within budget. So we really think these challenges are incredibly legitimate. We've seen the data on the percentage of projects that fail. And so it's important to note these challenges are really daunting for all organizations. With limited funding and resources, the ability to scale, to reach value has limited many industrial IoT projects. So why are we here? We believe we can bring success to IoT projects. We know it takes an ecosystem of relationships like with ZEDEDA, Advantech, and Dianomic. The diagram that you're looking at shows a few things. One, what we look at as our customers are what we call operational technology or OT partners. We heard it during the keynote, but just you're going to see a few acronyms, so I just want to spell them out over the next two slides. So we look at those OT partners as the general contractor to the end user. We bring together the industrial solutions at scale from partners like Advantech, ZEDEDA, and Dianomic, along with our relationships with service partners, domain experts, and hardware providers. And you can see those organizations in kind of the cloud area. So there's a lot of components associated with these types of deployments, and it's our job to bring them together. So if you're focused on the enablement of operational technology and are really that enabler, not the end user, we should have a deeper conversation on what Arrow's doing and how we can support IoT projects. Also, if you're a service provider to the industrial space and you want to expand your business into industrial IoT projects, we should also chat about how we can support the growth of an IoT practice. So if you go to the next slide. And this is a build. So to clarify and add some details, I wanted to put together a view with maybe some more specifics and showcase a value chain. So in the view of this model, we start with the end user in mind. And it's really from the end user perspective. So the end user requires skills and services that they don't have in-house or they don't have available. And so they go to an OT channel partner. The operational technology channel is there to support those end users. And like I said, those are the customers that we focus on. And we really look at them as enablers of intellectual property to that end user. So if you build again, those organizations or our customers work with independent software vendors and Arrow to bring together software and hardware IP. And then if you build one more time, we source products from technology vendors. So that's what the value chain looks like. And granted, this is a very simple overview, but highlights, I think, a few of the challenges in that value chain. For example, on the right-hand side, how do you validate the hardware and software work together? What about cellular connectivity for remote applications? Or as you move from move to the left towards the end user, how are these things going to be installed? Are they certified for all the countries and regions where they'll be installed? Finally, and I think most importantly, when something goes wrong, and it will, who does that end user call? So those are the challenges that we really look to solve, and questions that we look to answer, both ideally through proof of concept, but also in production. And look, we know this is complex, and I think we've heard that a few times today. I think the statement was said in both the keynote and the panel, right? If you want to go fast, go alone. If you want to go far, go together. Seems like the phrase of the day, but it really does exemplify, I think, this value proposition. So in the interest of time, and I think, if we wanted to take some questions, I'll stop there. But I know we've got maybe one more slide to close it out.
Okay, thank you, Roland.
You got it.
And thank you all for taking the time and speaking with us today. We have one slide to build out here, and what we kind of showed today was, we didn't talk about, we're kind of part of the infrastructure that kind of pulls all these pieces together. We had hardware discussions from the Advantech folks and Dianomic with the apps, Arrow kind of tying all this together. And what we really get out of this, the benefits of today is we have a use case of trying to get this data out of the plant, and you've got a clash between the IT and the OT side. What we heard of today was some vendors that have experience both in the IT and the OT side for domain experience. It allows customers to get best-in-class hardware, have an open system from the hardware to the application on top, to the services to build out their stacks to support the use cases that their business is demanding, whether that be connecting to Azure IoT services, Google. We saw some on-prem solutions today. But really, the theme of our company as ZEDEDA and our today is really the ability to be open in your approach and select best-in-class tools to support your use cases. So with that, I want to thank our speakers today, Roland, Tom, and David. We really appreciate you guys supporting us and bringing your expertise to this panel for our audience. And so with that, I think we're going to wrap up this session and allow people to get transition to the next session.